This problem says find the distance between the 2 points A, 6, -2, and B, 2, 1. So the first thing I'll tell you about, in case you don't already know it, is how to read this type of notation. And the next thing we'll do is look at the way to compute distance between 2 points in a 2D coordinate system. So what I've drawn here is called the XY coordinate plane. This right here is a real number line, which we can call the X. And this right here is a real number line, which we can call the Y. And this intersection point, the origin, is where the 0 of the X intersects with the 0 of the Y's. And so every point in this coordinate plane can be specified by an ordered pair. So the first number that shows up right here would be a number. In this case, I just wrote A, since it could be any number. And it is how far along the point is. The point P is in the X direction. And then the second number is where along the Y-axis the point is. So this is the name of the point, which is usually drawn as a capital letter, but it could be a lowercase letter, but typically it's a uppercase letter. And then the first number or variable is the location along the x-axis, and the second number is the location along the y-axis. So this number, 6, -2, let's erase this and start to do this. Let's say that here are some points, some 1, 2, 3, 4, 5, 6. 1, 2. So this, where the perpendicular line to 6 on the x-axis intersects with, oh, you see I've already made a mistake. This is usually the positive x direction going to the right, and this is the positive y direction going to the left. So 1, 2, 3, 4, 5, 6. Positive 6 in the x direction, -2 in the y direction. So this is where point A would be according to this notation. And point B is 2, +2 in the x direction and +1 in the y direction. So 1, 2. And 1. So this would be point B. I suggest you get some graph paper, or if you don't have graph paper, just make some tick marks on some XY axes, and you can plot some points. So anyways, after that rushed description of how coordinates correspond to points, we need to know how to figure out the distance between these 2 points. Now that we can kind of see them, the distance is, of course, this straight line between A and B, or between B and A. Just pretend that that's a straight line. My drawing is not great. How do we find the distance of this? If these were both on the same horizontal or the same vertical, it would be extremely easy. Fortunately, we can draw some extra construction lines here. So what you can see here is very much a form of right triangle. The only question is, we got to figure out what is this and what is this. Luckily, we have the ability to find that because this length right here is all on, as you can see, it's on the y position -2. And we know that this coordinate A's x position is 6. And we know the x position of point B is 2. And so now this is reduced to a single axis problem. What's the distance between 2 and 6? It's the absolute value of 6 minus 2, or the absolute value of 2 minus 6, which is 4. And similarly, see if you can figure out, given that this point B's y position is 1 and this A coordinates y position is -2. So if this is at 1 and this is at -2, what is the length of this? Right, it's 3, because the absolute value of, say, -2 minus 1, or 1 minus -2 is 3. And now, to figure out this, if you know the Pythagorean theorem, if you don't know what the Pythagorean theorem is, you can look that up. I won't go through the proof. That would take quite a bit more time. But we know if this is we'll call this some value A, and this some value B, and we know that this is a right angle. How do we know this is a right angle? Because this line is perfectly horizontal because they have the same y value. And this line is perfectly vertical since they share the same x value. So the Pythagorean theorem, if you don't already know it, is that given a right triangle, the value of the square of the hypotenuse, c squared, is equal to this side's length, a squared, plus the square of this side's length, b squared. So I'm going to erase some marking here to make some space. This means that this is the distance. We'll call this D. The distance between points B and point A. We know that D squared is going to be 4 squared plus 3 squared. 4 squared is 16. 3 squared is 9. So D squared is going to be 16 plus 9, which is 25. Well, if D squared is 25, what is D equal to? What number times itself is 25? 5. So that means that D equals 5. And D is the distance between points A and B. So the distance, the answer to the question, is 5. Points A and point B are 5 units away from each other. And what we worked out just a minute ago was a specific instance of this problem, but what I've written out here and what you can verify by substituting abstract values, say x1 and y1 for the x and y coordinates of a first point, which you can call P1, and x2 and y2 for the x and y coordinates of another point, P2. So for any 2 points, the formula for the distance between those 2 points, which you can do by graphing them and looking at it as a Pythagorean theorem problem, the distance will be the square root of the square of the distance in x values between the 2 points plus the square of the difference in y values of the 2 points. So this is a general formula that you can use when you know the x1 and y1 of a point and the x2 and y2 of a point. This problem says, sketch the graph of the equation y equals -1/2 x cubed. Here are some pictures that explain some terminology that you'll come across. You know, an equation is an expression that says something is equal to something else. And then a solution set is all of the sets of ordered pairs, because an expression could involve some x1 and y1. And so the solution is all the values of x1 and y1, which when substituted in everywhere an x1, an x or a y appears in this expression, solves it. So there may be one x1, y1, which when substituted all the x's for the x's in this expression and all the y's and wherever they show up, makes it true that the expression on the left equals the expression on the right. There may be multiple, there may be only one, there may be no sets of ordered pairs that satisfy. It depends on the equation. But the solution set is all of the ordered pairs that solve the equation. And then the graph of an equation is the points which correspond to the ordered pairs of all the solutions. So that's a little terminology right there that we'll use in the solution of this problem, which says to sketch the graph. So we need to have these points. To have these points, we need to find the solution set. To find the solution set, we need to look at the equation. So here's a very simple beginning technique, which is a good place to start. Plot a few points corresponding to ordered pairs in the solution set, and then fill in the rest of the points. So we'll do that with this example. This doesn't always work, but for simple equations, it's usually a good enough technique. So with this equation, it's very easy to find out which ordered pairs are solutions, because as you see, y is all by itself. So you can just plug in as many values as you want of x, and then compute the value that y gets when x is what you plug into it. So go ahead, I encourage you to figure out when x is -3, find out what's -1/2 times -3 cubed, and go down with the rest of these. So here we are. If you compute the value of y for these values of x, you get -3 corresponds to 13.5, -2 is 4, -1, 1/2, 0, 0. And then with the rest, you can see a pattern here, how this is symmetric about the origin. And maybe in a later problem, we'll talk about what exactly I mean by symmetric about the origin. So now that I've plotted these points, the question is, how do we fill in the rest? And one thing I will tell you is that when a problem is linear, when the exponent on x is just 1, then you will have the equation with a straight line. But because we have a 3 here, if we had a 2 or a 3 or a 4 or more, you will notice as you get further along in doing these types of problems that the smooth line connecting these couple of points that you plotted will be not linear, not a straight line between these 2 points, but a curved line will fit them. And once you've done this, take your hand at trying to do your freehand skills. Try to make as smooth a line as you can connecting those points, and we'll see how your line looks. And so here I've done as best I could to draw my curve fitting these points, so that this is the graph of the equation. And like I said, when we get into other techniques, we'll find different ways than just plotting a couple of points and connecting them with a smoothish line. But for now, this is pretty good. This problem says, sketch the graph of the equation y equals 2 minus 3x. And looking at this expression, x and y both have an exponent of 1, and only arithmetic operations are present. So by inspection, this is a linear equation, and the graph of the equation is a straight line. So as you can tell by looking at a straight line, all you need are 2 points, and it's very easy to fill in the rest of the graph with a straight edge or a steady hand. So we can pick any 2 values of x to find the corresponding y value of the solution, which is what we'll do when we draw our coordinate axes. So here we are. I picked 2 values of x to find the corresponding values of y, but you don't have to use these values. Like I said, you can use any 2 values, but I chose 0 and 1. And now on the table here, we'll plug in x equals 0 here to see what y is. 3 times 0 is 0. 2 minus 0 is 2. So when x is 0, y is 2. Now, when x is 1, 3 times 1 is 3. So 2 minus 3 is negative 1. So here we are, 2 points. And once I draw some numbers on this axis, here we go. So 0, 1 would be 0 on the x-axis, or 0, 2, I'm sorry. 0, 2 is 0. Right here. And 1 minus 1, 1 minus 1. Now we've got 2 points. So now it's just left to draw as nice a line as we can. That was lucky. So this is a graph of the equation y equals 2 minus 3x. And what you can notice is the y-intercept is the 2. That's where it crosses the y-axis. And the slope, just a sneak peek, we'll talk a lot about slope in calculus. The slope is 3 because every time it goes forward 1, it goes down 1, 2, 3. So there's the sketch of the equation y equals 2 minus 3x. This problem says, prove that the triangle with vertices E, -3, 4, F, 2, -1, G, 9, 6 is a right triangle, and find its area. So obviously, to answer this question, we need to know what property right triangles have. So think about that. What property is it that defines, well, is characteristic of a right triangle? If you have to think about it, go ahead and pause this video and think about that before I give you a hint. Here's the hint. So I wrote down Pythagorean theorem. Do you remember what that is? If you do, then you'll know that if you have a right triangle and you have the perpendicular sides, the sides that are connected with a right angle, A and B, then the longest side, C, will have the property C squared equals A squared plus B squared. So before we move on to solving this problem, let's do the graphing of these. Why don't you get out a piece of paper and draw some coordinate axes and take a look at these points in the plane. Okay, here's a bit of an XY coordinate plane, scoped out large enough to show these points. These are the points we want to plot. Let's start with point E, which is at -3 on the x-axis and 4 in the y direction. So remember, the first one is the horizontal axis, -3. So this is -1, 2, 3, and 4 in the positive y direction. So 1, 2, 3, 4. So we can draw, I'm just going to write the point right here. I'm not going to put the coordinates in parentheses just to keep it clean. Now F is at +2 in the x direction and -1 in the y direction. So this is F, and G is at 9, 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. About right there. I'm going to go ahead and erase these construction lines. And now to make it look like a triangle, I'm going to get out a straight edge and try to connect these lines with fairly straight lines. See what it looks like. Okay, here it is drawn. And what you definitely don't want to do is conclude, oh, it must be a right triangle because it looks like one. That would depend upon one's artistic skill or visual acuity. And also, you don't even have to guess which of these is the right angle. Or it could be this one, but it's probably not because that doesn't look very close. It's probably this one, but what we want to do is make our answer dependent upon finding the, what do you think? We want to find the distance between each pair of points to find the lengths of this triangle. And remember the Pythagorean theorem, which of these would be the longest? The one that's one of the ones that's close, adjacent to the right angle, or the one that's opposite of the right angle? It's the one that's opposite of the right angle. So whatever one of these is the biggest, its square has to be equal to the sum of what? Whichever of these is the longest, its square has to be equal to the square of the other sides. So we got to solve for 3 distance equations. So if you remember the distance equation, what we need to do is remember the distance equation. Let's say we have 2 points P1 and P2. It's the square root of So we want to do this with points E and F first. Okay, so this is the distance formula. And here is our data for E and F. We're going to take the square root of, and x1 and x2 are the first values in the ordered pairs here. So let's take E. What's the first value? It's -3. I'm going to subtract, what's the first value of F? 2. And we take the square of the distance in x coordinates, and we add the square. What's the y coordinate of E? It's 4. Minus What's the y coordinate of f? It's -1. Okay. So -3 minus 2 is -5. And -5 squared is 25. And 4 minus -1 is 5. 5 squared is 25. So the distance is the square root of 50. So that's going to be the distance in whatever units these are, inches, centimeters, miles. Let's leave it at that. We'll say the distance between E and F is the square root of 50. Now we've got this side. Now let's find this side. The distance between F and G. Go ahead and pause the video and find out the distance using the distance formula. Here it is. I applied the distance formula right here. This is the x position of point F, and this is the x position of point G. This is the y position of point F, and this is the y position of point G. 2 minus 9 is -7. -7 squared is 49. -1 minus 6 is -7. -7 is 49. And 49 plus 49 is 98. So this distance is square root of 98 units. Almost done. We've got to find out the distance between points E and G now. Okay, try to figure that out. I'll pause the video. So here it is. The distance between E and G is the distance between -3 and 9 squared plus the distance between 4 and 6 squared. So this is -12. -12 squared is 144. The distance here is squared is -2 squared, which is 4. 144 plus 4 is 148. So now we have the actual lengths between these sides. And you remember the Pythagorean theorem looks like this. Let's call it the longest side, the hypotenuse, C, and then the other two sides, A and B. See how these are all still within square roots? So if these are the actual sides. Let's call this A and B and C, because we can tell this is the biggest side. So now we can tell that this is the hypotenuse. Now, to make sure that this squared equals this squared plus this squared, because that's the criterion for it being a right triangle, the square root of 148 squared is 148. And then the square root of this squared is 98. And the square root of this squared is 50. And check if that's right. Is 98 plus 50 148? Yes, turns out it is. So since this length squared equals this length squared plus this length squared, that is the proof that this is a right triangle. Now we are supposed to find the area, but before we jump into it, let's figure out how to do that. Just a refresher, if you didn't know the formula for the area of a triangle, the formula is given, if you know one side, which you call the base, because you lay the triangle on a table and the base is the flat side. And then the total height is h here. See how you can have any kind of triangle. This one happens to be a right triangle where the height is the same as the side because it's perpendicular to the base. In this formula, the area is 1/2 base times height. In this one, in this triangle, you have the base, and now the height happens not to be one of the sides because both of these are acute angles, and the line going directly to the top is not corresponding exactly to one of the sides of the triangle. But if you did know the height, you could say use the same formula, 1/2 base times height. And if you have an obtuse angle where the straight line from the peak down to the base floor is outside the triangle, once again, you need that height to be able to use this formula, but once you have the height, it's 1/2 base times height. So going back to this problem where we have the 3 side lengths, but you remember from the drawing, the triangle was rotated at a different angle. Fortunately, once you have the 3 side lengths, you can orient it how you want. Now this is a possibility. You make the base the hypotenuse, the longest side. Do you see the problem? This height is not one of the numbers that we currently know. We would have to do some fancy trigonometry to find out what this height is. And so this choice is not as convenient. But this choice, look, since it's a right angle, we know that the height going straight up is perpendicular to the horizontal flatness of the base. And in this case, we have the base and we have the height. So ask yourself, when you're looking at a figure, where the right angle is and which would be a most convenient pair of sides to pick, to choose to be the base and height. And what I'm going to choose is to be the square root of 98 as the base and the square root of 50 as the height. Or it would have been just as easy to flip this over and make the base and this the height, but it's definitely much better than having the base be the hypotenuse. So we're going to take these 2 values and plug it into this. I encourage you to do that as I pause the video. And let's find out what the area of this triangle is. So if I didn't make a mistake, the area in square length units, whether it was inches or centimeters, it didn't say, but we know that the area is in square length units. If I got the numbers right, I get the area being 35 square inches, square centimeters, whatever the lengths are measured in. And hopefully that's right. So that's the area of the triangle specified by these 3 points. This problem says, find the center and radius of the circle with the equation x squared plus y squared plus 6x equals 0. This one requires some thought because it's not telling you exactly what formula to use, obviously. But if you haven't done a radius and center equation before, it might be useful to start out small and build up how to solve this type of problem, and then use that to solve the problem. So let's start. So let's step back and ask, what is a circle? Or how could you describe one mathematically? Well, you know what circles look like. We could draw one right here. So here's a circle. How do we describe it mathematically? Well, if we don't have any intuition on where to start, sometimes you read the problem again. You look for keywords that help you to solve the problem. Scroll back or remember, what did the problem say? Things about center point. What else? Radius. Let's draw the center of this circle right here. it's a point, right? It's the middle of the circle. And the radius is the distance from the center to the edge, right? Okay, so here we have this. How can we describe a point mathematically? Right. If you said an ordered pair, we could call this XC, X sub C, the center X coordinate, and the Y sub C. We could call this the center using that notation. And the radius is just the distance from the center to the edge, and property of a circle is that all the points on the circle are equidistant, or the same distance from that point to the center of the circle. Okay, these are good things to describe a circle mathematically: center point and radius. Let's try making a circle with a very simple center point. Let's say that we have our X, Y coordinate system. Let's say the center is right at 0, 0. And let's pick a simple radius value. Let's look at a circle centered on the origin. Let's say that the radius is 1 unit. Let's draw it zoomed in, pretty nice and big. Hopefully that's close enough to looking like a circle. Okay, that means that at this point on the circle, it's going to be 1. So this point's going to be on the circle. This point's going to be on the circle. Same as this point and this point. Everywhere 1 unit away from the origin is going to be on the circle in this case. So, excusing my poor art skills, let's say we want to talk about this point right here. Let's give it a name, X, Y, where X is some value and Y is some value. Okay, then what's this distance going to be? It has to be 1 because it's the same radius everywhere around the circle, right? Now, how can you say that the radius is 1 using the distance formula that we used earlier? Remember the distance formula? This point right here, the distance is the distance from 0, 0. Let's call this point P using our consistent notation. We're calling this point P, which is at X, Y, where X and Y are specific values for this point on the circle. How do we find the distance from C to P? Go ahead and pause this video, and if you need to go back and look at the distance formula, try that. What I've drawn here is the distance formula for the 2 points, the center, which is at 0, 0, and this particular P, which is X, Y. Okay, so remember the distance formula. It's the square root of the difference between the X coordinate values. In this case, the X coordinate of P is this X, and the X coordinate of the center is 0. And then the square of the distance in the Y direction between the point, which is Y, and the Y direction of the center, which is 0. So What does this all equal? It equals 1 because everywhere on this circle, the point on the circle is 1 unit away from the center because the radius is 1. So look at this for a little while. Now what I've done is, having a big square root complicates things, but we can say that the distance squared, the radius squared, so what I did was I squared both sides so that it's equal to just what was inside the radical. And we know that 1 squared is the same as 1. Also, since this simplified example, anything minus 0 is itself, so we can also just write it as x squared plus y squared equals 1. So this equation right here describes a circle with center 0, 0 and radius 1. Now let's do another example where the center is somewhere else and the radius is some other value than 1. Try this next example, and if you need to use your notes that you've been taking, or if you have some other notes, go ahead and consult them if you need to. How would you write the equation of a circle given that you know the center is at the point 5, 7 and the radius is 8? And in a second here, if you haven't been able to do that, we'll draw a picture. And here's a picture if you're still working this problem out. And what we want to get, what is wanted, is the equation for the radius as a function of the distance between point C and anywhere on the circle. We've picked this point P, which has an abstract xy. So remember the distance formula and what I said in the previous example, how it's a lot simpler if you just talk about the distance squared. So we're saying that the distance squared, here it is drawn as a right triangle. Let's say that this is so how do you describe this right here? Well, we know that this is x7, right? Because this position. But what we want to do is if we're talking about x and y, we can draw them right here. And we always say the difference between, right? The distance between this part and this part and this part and this part. So what number do I put right here? This x is at some, this point P is at some, in the x direction, it's at x, right? We're saying that x represents a number. And this, what is this? Is this 5 or 7? Which one represents the horizontal axis? It's the first number, right? So the distance between x and 5 is x minus 5. And if we're talking about this, we know that this, in the y direction, this is the number, the value, y. What is this? It's 7, right? And so what is this distance? This is y minus 7. So The question was, what's the equation of a circle with the center at 5, 7 and the radius 8 units? This is the equation. This is the radius squared. This is the x position of the center. This is the y position of the center. And for any point, we take that point's x value, right, and plug it in right here. We take that point's y value and put it in right here. And this is the equation of this circle. And so in the next example, we'll say not a specific number, but we'll say that the center is at some arbitrary point and the radius is some arbitrary value. We'll see that. So now we'll just do it where we use variables which could stand for any specific numbers. I said, what's the equation of a circle centered at some point C with coordinates hk and the radius r units? If you can do it without drawing a figure, but it's always good to draw a figure. There's no reason to make it hard for yourself. I encourage you to draw the figure and see if you can visualize that triangle or remember the distance squared formula and see what we get. Here it is, this formula right here. We can say r squared equals x minus h squared plus y minus k squared. And remember which of these are the ones that are the points on the circle and which ones are the parameters of the circle. This x and y are the ones that are the points on the circle, and the r and the h and the k, the r is the square of the radius and the h is the x position of the center point and the k is the y value of the center point. One last thing I should say is, see how I've always been using minus, because we're talking distances here. When you have 2 points, you take the difference between the 2 points. And in the next example, I'll show you what it means when sometimes you have a plus in there. Take a look at this question. It says, the equation of a circle is 64 equals x plus 2 squared plus y minus 4 squared. Then what are the radius and center of the circle? Hopefully you'll be able to do this given the couple of examples we've done. Go ahead and pause the video and think about this and then unpause it. Do you remember the distance squared equation for a circle? Remember, it's like this. For a circle centered at hk with radius r, the formula is, and you can always derive this if you want to see why it works, by picking a center point, picking a arbitrary point, and converting it to a right triangle problem. But once you've done that, you can see that this is always a minus because of you're wanting the distance. So what do we do here? What we're given is a plus. Sometimes you have to do a little massaging on an equation to get it in the form that you want. what is x plus 2 equivalently as? What is the question mark here? If I want to make it, I need a minus right there. Minus 2. Even minus 2 is the same as x plus 2. And this is already in the form that we want it to be. So I keep on writing D, but in this case of a circle, we want to call it R because radius, you know. I wrote the abstract form right below it so that we can map these numbers to what they are in the equation. So if r squared is 64, then what is the radius? What's the square root of 64? That means the radius is 8. Now, I got it into this form. I changed it from this form to this form because I know that the circle's formula looks like this. So the center, this is the x coordinate of the center, is -2, right? And k, the y value of the center, is the value right here. It's 4 because it's y minus k. We have y minus 4. This h, you know, the x point, x minus -2, that means that the center's x coordinate is at -2. And the center is at -2, 4, and the radius is at 8. So that's the answer to that. And now, hopefully we know enough to be able to make something of the original problem. So the question is, are we there yet? Do we have in this equation the form that we can easily read off the center and radius? Unfortunately not. But now we're going to talk about, if you haven't learned it before, how to get an equation that has x squareds, y squareds, x's and y's and numbers into this form by using a technique called completing the square. So you wanted to expand this. If you haven't worked with binomials before, this is a binomial. Bi means 2. There's 2 things here. And we're raising it to the power 2. What does this mean? It means you're taking x minus h and you're multiplying it by itself, right? So we can write it like this. And have you ever multiplied x minus h times x minus h? Can you see how this would be done? Well, you got this x squared, and this one times this one, x times minus h is minus xh. Now you're done with this one. Now we're doing minus h times x minus xh, or hx, it's the same thing. Now minus h times minus h is plus h squared, right? So we've got x squared. We've got 2 minus xh's, so we can just write minus 2xh. We've got plus h squared. So now I've gone from this form to this form, and since I've used arbitrary variables, we can say that x minus h squared is the same thing as x squared minus 2xh plus h squared. So if we can get something into this form, we can write it as this simpler form. So instead of directly trying to get this by looking at what we've got, if we can get into this form, which you'll see in a minute, then we can substitute this. So here at the top is the original equation that we're supposed to figure out what's the center point in the radius. And down here I left the key of what we can do to get part of the distance squared formula that we want. So take a look at this. Which pieces of these would you pull out to work with, given that we want to do something with this? Is it worthwhile to plug the y into any of this? No. We can use this. And now we can also use this. This is positive, right? And this is a positive 6x. But what we need is to have minus 2 times x times some h plus some h squared. Okay, so this is a lot closer to this than this is, but this is what we've got. So what do? X squared and x squared, these two are exactly alike, but this is what we need. And this is what we've got. So what would you do? Do you have any ideas? We need a minus 2 here, but we've got a 6. Well, we can start to do this. Right? Let's do this. We know there's going to be an x right there, and we've got an x. So let's just not draw it. So 6, positive 6 equals negative 2 times what? Negative 3. So that means that we can rewrite this as x squared minus 2x times negative 3. And look, what does that mean h is? It means h is negative 3. And what is right here? What do we have to add to make it just like this? H squared. What's minus 3 squared? It's a 9. But you might be thinking, we don't have a 9 right here. We're stuck. Well, completing the square means that we can add it to both sides. We want a 9, we'll just add a 9. And then, since we've added a 9 here, we'll just add a 9 right here. Now this is getting messy. Let's clear this out. We said that we can convert x squared plus 6x we know that we added a 9 here, and we added a 9 to the other side. But the good thing is, look at this. This is the form that we need to be able to convert it into this. So now the thing to do is see if you can figure out how to convert this, what the nice, more compact version is, now that we have figured out what h value. Whoops, I almost forgot something important. Let me just write 9, because we know that 9 is negative 3 squared. Right? X minus, what is h? H is minus 3. So we could write minus 3 is x plus 3. All right. That means that we've got we took care of this and this. And we added 9 to get this completed. We added 9 on this side. Is this the distance squared formula of a circle? Pretty much, but remember the distance formula was like radius squared equals x minus, we want to keep it in the form that is exactly so if we just have a y and we need it to be in this form, I think it's pretty obvious what to do, but what does this mean that the k value is? It just means that the k value is 0, because y squared is the same as y minus 0 squared, right? So we can write it this way. Let's write 9 as 3 squared, because we know that the formula is for radius squared. And I think we're just about done. Can you tell by reading this what the radius and the center point are? It was a lot harder in this form, but because we've completed the square, we know that these two are identical. And from this, we know that h is negative 3, k is 0, and r is 3. So the center is at negative 3, 0, and the radius is 3. So in this problem, we worked on how to define circles mathematically, and we looked at the distance radius squared form of a circle. We looked at completing the square. So we learned a lot in this problem. I encourage you to look at a lot more circle problems like this.